Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to know about trigonometric equations. A trigonometric equation is an equation which contains trigonometric functions of variable angle. Example: sine theta is equal to 1 by 2. Twice sine 2 theta plus sine square 2 theta equal to 2 are trigonometric equations. Let us consider a trigonometric equation sin x equal to 1 by 2. The values of x which satisfy this equation are called its solutions. We know that when sin x is equal to 1 by 2, then x is equal to 30 degree or pi by 2 radians, because we know that sin 30 is equal to 1 by 2 or sin pi by 6 is equal to 1 by 2. Thus x is equal to pi by 6 is a solution of this trigonometric equation. We also know that sine of pi minus theta is equal to sine theta. Therefore, sine pi minus pi by 6 is equal to sine of pi by 6, that is equal to 1 by 2. Pi minus pi by 6 is equal to 5 pi by 6. Therefore, sine 5 pi by 6 is equal to 1 by 2. Since 5 pi by 6 radians is equal to 150 degree, therefore x is equal to 150 degree or 5 pi by 6 is also a solution of this equation. Thus from 0 to 2 pi, that is x greater or equal to 0, less than 2 pi, there are two values of x, that is pi by 6 and 5 pi by 6, which satisfy the equation sin x is equal to 1 by 2, and these values of x are called principal solutions. Thus we have two principal solutions in a trigonometric equation. This is because every trigonometric function is positive or negative in two quadrants. In this case, sin x is equal to 1 by 2, which is positive, and sine is positive in first quadrant and second quadrant. Therefore, x is equal to pi by 6, which belongs to first quadrant, and 5 pi by 6 belongs to second quadrant, or its principal solutions. Now also we know that sine of 2 pi plus theta is equal to sine of theta. Therefore, sine 2 pi plus pi by 6 is equal to sine of pi by 6, that is equal to 1 by 2. 2 pi plus pi by 6 is equal to 13 pi by 6. Therefore, sine of 13 pi by 6 is equal to 1 by 2. Also, sine 3 pi minus theta is equal to sine theta. Therefore, sine 3 pi minus pi by 6 is equal to sine of pi by 6, that is equal to 1 by 2. 3 pi minus pi by 6 is equal to 17 pi by 6. Therefore, sine 17 pi by 6 is equal to 1 by 2. Thus, if we rotate in anti-clockwise direction continuously, we get values of x as pi by 6, 5 pi by 6, 13 pi by 6, 17 pi by 6, and so on. That is, we get infinite values of x which satisfy the equation sin x is equal to 1 by 2. We can express all these values of x by x is equal to n pi plus minus 1 raised power n pi by 6, where n is an integer. If n is 0, then x is equal to pi by 6. If n is 1, then x is equal to pi minus pi by 6, that is 5 pi by 6. If n is 2, then x is equal to 2 pi plus pi by 6, that is 13 pi by 6. If n is 3, then x is 3 pi minus pi by 6, that is 17 pi by 6, and so on. X is equal to n pi plus minus 1 raised power n pi by 6 is called the general solution of sin x is equal to 1 by 2. The general solution represents every possible solution for a trigonometric equation. Now we will do an important result on trigonometric equations, and that is, here if sine of x is equal to sine of y, then we have to prove that x is equal to n pi plus minus 1 raised power ny, while n belongs to set of integers. So since we have sine x is equal to sine y, so we write sine x equal to sine y, or sine x minus sine y equal to 0. Now we know that sine x minus sine y is equal to, it is twice cos of x plus y divided by 2 sine of x minus y divided by 2 equal to 0. 2 cannot be equal to 0, so we have either cos of x plus y divided by 2 equal to 0, or sine of x minus y divided by 2 equal to 0. Since we know that cos is 0 at odd multiples of pi by 2, so we can write x plus y divided by 2 is odd multiple of pi by 2, that is 2n plus 1 into pi by 2. Also, sine is 0 at integral multiple of pi, so we can write x minus y divided by 2 is equal to n pi, or it is x plus y is equal to 2n plus 1 pi, and x minus y is equal to 2n pi. Further, x is equal to 2n plus 1 pi minus y, and here x is equal to 2n pi plus y. Now in this case we have odd multiple of pi minus y, and in this case we have even multiple of pi plus y. So we can write, if we combine these two, then we can write x is equal to, it is odd multiple of pi, this is even multiple of pi. So we write n pi, which represents both odd as well as even. Then here it is minus and here it is plus, so we write plus minus 1 raised power n, then we have y. Now in this case it is odd, and in this case it is even. When n is odd, you will get minus. When n is even, you will get this one, that is plus. Therefore we have proved that when sine x is equal to sine y, then x is equal to n pi plus minus 1 raised power n y. That completes the result. Now, in my next lecture, we will do some more results on trigonometric equations. Till then, take care of yourself. Thank you.